Yeah, so I'll be giving an introduction to Dockstore or to Docker, and I'll be connecting it back to Dockstore a lot because obviously that's the point of this lecture. But first, I'll give some background on what Docker is. However, before we can learn about Docker, we need to understand the concept of a container. So a container encapsulates all the software dependencies associated with running a program. It allows for portable software that runs quickly and reliably from one computing environment to another. We can see in this image, there's the three different containers above the whale. And if you look at the first one, there's GATK, Java, and R installed. So a user who's running this container would not need to worry about installing these software packages themselves, and this would save them a lot of hassle. So where does Docker fit into all this? Docker is actually a popular brand of container. You may have heard of some other ones, such as Singularity, but that's beyond the scope of this tutorial, though we will link to some documentation on it at the end of this in our take-home workshop. Okay, so Docker and containers in general, they help us solve a lot of problems. First, there's installation problems. These problems are related to installing the software that we want to run. So perhaps the software is built on a different OS, or maybe there's install documentation, but it's unclear, or maybe it's out of date. So that kind of makes it hard to do an install. Whereas the Docker image would have this software bundled up already. So the user wouldn't need to worry about any of this installation, and you wouldn't run into these issues. Next, there are dependency problems. These problems are related to the dependencies required to get the software working. So for example, software may require a different version of Java or Python than what is available on the machine. Or perhaps you have multiple programs you run on your computer and each rely on the same dependency, but they rely on different versions of those dependencies, so maybe different versions of Python. Using containers resolves this dependency because you can isolate these environments and have it self-contained. Finally, there's these portability problems that it solves. Things might work on one system, however, not on one used by one of your collaborators, which I'm sure a lot of you have faced before. Instead of having to support multiple systems, you could simply use a container. For Docker's case, a Docker container will run on any host that supports Docker or has Docker installed. Okay, so now that we understand what containers are and what Docker is and what problems they solve, we're going to focus on some Docker concepts. So in Docker speak, a container is a running image. It is packaged up, isolated software environments. It has all its dependencies installed. Whereas an image is packaged up code with all of its dependencies, but at rest, and that's the key difference. The terms container and image are often used interchangeably, and as I've said, this isn't exactly true. Images allow for portable software that runs quickly and reliably from one computing environment to the next. And there's also official Docker images from Docker Hub. These images are regularly updated and scanned for vulnerabilities. And finally, there's the concept of registry. So you may have heard of some of these registries listed here. And a registry is simply a repository where users can store images, and this could be private or publicly, and it's done on the cloud. One common confusion is, does Dockstore store images or host images? We don't, but rather we get these images from these image repositories. And again, here are some of the main ones that Dockstore supports. So there's Docker Hub, which is the official one. There's Key.io, and there's Google Container Registry. So this slide is showing a high-level overview of the Docker ecosystem. So on the left-hand side, you can see there's image registry. So this is the ones I was just talking about, and this is where these Docker images are stored and where they're shared from. On the right, there's the host machine, and this is one thing you can see is the Docker daemon. So this is a service that's running on your host machine and does a lot of the heavy lifting. The Docker CLI, which is also on the host machine, is a command line tool for interacting with this Docker daemon. There are a few commands that we show here in this diagram, and I'll go into them in a bit. There's also, as you can see, the images and containers, which are stored on the local, on the host machine. And these images could come from an image registry, or they could be locally built, and we'll go more into that in a bit as well. So this slide is going through that first command, which is the Docker pull, and just looking at it from a high level perspective. Um, so Docker pull will first pull, so pretty much you give Docker pull a image that you're interested in, and that image is located on the image registry. That will be pulled and downloaded onto the host machine, and now you have that image stored on your machine. This slide is showing how the Docker run command works. So it's what you actually will be running for when you actually want to run these containers. And what it does is it'll take an image that you have and it'll instantiate it and create a running container. One thing to note is the Docker run will actually perform a pull if the image doesn't already exist on the machine. So if this is your first time running an image, or perhaps it's updated, it'll actually pull from the image registry where it's supposed to come from.